everyone, my name is Linda Lim, and today I'd like to introduce to you the C-V2X application in ITS that we may soon be able to see in the near future. This new ITS application can help improve safety on our roads as we start to see more autonomous network get integrated in our environment. So to start off, what is C-V2X and its capabilities? C-V2X, which stands for Cellular Vehicle to Everything, is a unified connectivity platform designed to offer vehicles low latency connection with its surrounding environment. This includes V2V, vehicle to vehicle, V2I, vehicle to infrastructure, V2P, vehicle to pedestrian, and V2N, vehicle to network. These systems are all integrated to be able to communicate with one another, which is what makes it connected vehicle to everything and is the main core benefit for improving roadway safety. So what are the benefits to C-V2X? According to statistics, nearly 1.35 million people die in road accidents worldwide every year, which is equivalent to about 3,700 deaths per day. Car crashes have risen to the 8th leading cause of death globally, and C-V2X is becoming a popular solution to this problem. Typically, autonomous driving vehicles are equipped with advanced sensors such as camera, LiDAR, radar, GNSS, and CAM. This will enhance blind spot detection, long-range perception, remote driving, and platooning, which can increase road capacity, driver safety, and comfort. There are several C-V2X applications. They include SPTA, signal phase and timing, TSP, which stands for traffic signal preemption, VRUCW, which is vulnerable road user collision warning, ICW, which is intersection collision warning, EBW, which stands for emergency brake warning, DNPW, which stands for do not pass warning, and lastly, we have HLW, which stands for hazardous location warning. All these applications are designed to be integrated into a network through advanced messaging system, which is what C-V2X is centered around, and is the reason why this type of technology can enhance roadway safety. There are several solutions in which C-V2X can provide. The first is traffic light control system, and the architecture system for this is shown on this slide. It collects traffic light information from the light controller directly. Then, light signaling collection program is responsible for receiving roadside light signaling information, including light phase, color, and remaining time. The RCU reads and encapsulates them to C-V2X protocol messages. Then the RCU broadcasts C-V2X messages to the OBU via PC5 interface. The OBU is installed in autonomous driving vehicle, analyzes and filters these messages, and then sends them to the IPC. User interface displays this light information for intuitive C-V2X technology presentation. The second solution is VRUCW, which stands for Vulnerable Road User Collision Warning. It uses an AI server equipped with a series of deep learning technologies such as CNN and SSE. Objects will be detected if any pedestrian passes an area under camera coverage. The AI server transfers the analysis results with the object recognition and movement prediction to the RSU, which broadcasts this information to all the other OBUs under the coverage of this RSU. The OBU is responsible for combining vehicle information such as speed, heading, and location to determine if a collision is approaching. Supposing that there is a risk of collision between pedestrian and host vehicle, there are algorithms for a collision warning trigger. Another solution that C-V2X technology can provide are automated driving system integration, shown in this slide. How this works is that the RSU receives the information from traffic light controllers or AI servers. Then it broadcasts this information by using a predefined message format in its coverage field. Then the OBU receives broadcasting messages, which is then connected with industrial PC of the autonomous driving system. A warning message will be sent accordingly to the IPC of autonomous driving system. Finally, C-V2X technology is integrated with the autonomous driving system as a whole. Some potential challenges that come with C-V2X deployment. The first is that C-V2X is an ecosystem. There must be robust engagements from industry stakeholders like Transit Road Authority, autonomous driving developers, network transmission operators, and the government to all be able to work together in jurisdiction, just like we have learned in our modules. Plenty of privacy and confidential information from vehicles, roadway infrastructure, and cameras are all broadcasted in the public space as well. This may pose some ethical concerns. The third, Autonomous driving is defined as level 0 and level 5. However, there are no international standards for road level definition as well. Regulations and insurance claim for ITS road accidents are also yet to be defined. And lastly, 5G is still a year away from island-wide coverage, though it has completed LTE V2X service testing trials. The goal of C-V2X is simple. Deploying this sort of technology in order to start saving lives as soon as possible is safe and the most effective way. Additional considerations requiring this are: the first, reliability requirements for guaranteeing robust and continuous operation in harsh automotive environment. The second, securing C-V2X operation, fully isolating and protecting the C-V2X assets for secure connection. The third, regulations and insurance claim for ITS road accident. And in conclusion, the promise of C-V2X for safe, efficient, and greener transportation is closer than ever before in order to improve roadway safety. References used for this video are shown in this slide.